Day 12. What have we got? Because it's the last day. Hi and welcome to the PiHut Advent Calendar, the 12 projects of Codemas. We've got day 12. It looks like it's a big one, so let's have a look. Oh. We have something in an anti-static bag. Let's get the scissors out. Carefully cut. Don't want to chop what's inside. We have some LEDs. Let's get on with going to the web page and find out what we're supposed to be doing with them. It's an RGB LED strip. It's the final day of 12 projects of Codemas Advent Calendar. Today we're playing with the RGB LED strip, but these aren't regular LEDs. They're addressable LEDs, meaning we can code all sorts of colours, patterns and sequences. Time for some ultra festive blinky. Let's get the mouse there. Okay, warning. Some of today's activities contain flashing lights which may not be suitable for those with photosensitive epilepsy. So, as with the last Advent Calendar, which is actually the second one because this is the first one, but the point is, if you do suffer from these things, please be very careful. And even if you don't, still be very careful, because the thing is that from what I understand with this kind of condition, you find out the hard way. So, let's get on with doing it and see what we've got to do. Today's project. Today's a big one. We're going to learn how to light up the LEDs in our strip individually, how to code different colors and color lists, how to create a light chaser, then a light chaser speed controller using our potentiometer from day 4, some button color controls, then fading effects. Phew, definitely I feel like that after reading all that. Before we start, let's talk about what an addressable LED is. Addressable RGB LEDs. The LEDs in your strip are WS2812 addressable LEDs, sometimes called NeoPixels, which is a brand version from our good friends over at Adafruit. There are a special kind of LED and actually contain 3 small LEDs inside each, one red, one green and one blue, which we will mix to create lots of different colours with our code. This is why it's called an RGB strip, red, green, blue. We'll talk more about this in a moment. Each of these LEDs has a tiny chip inside that allows us to talk to them individually in our code, unlike other traditional lighting options which light the entire strip in a single colour. However, because of this, they always need a microcontroller to tell them what to do. With much longer strips, you would usually have to worry about external power, resistors and other technicalities. However, this compact custom strip in our box is short enough to allow us to avoid all of these distractions. We will be powering it from a different pin this time though, the V-bus pin, physical pin 40, as this will provide a full 5 volts that the strip needs rather than 3.3 volt pins we've used before. We've also had this LED strip made especially for this calendar with a handy jumper wires, so you don't need to mess around with connectors and tools. Okay. Step 1. Construct the circuit. Disconnect your Pico from the USB port on your PC so that it's safe to amend our circuit. Okay, let's make sure that's done. I often unplug from the last day anyway. So let's bring this across now. We're starting with a mostly bare breadboard, so remove any other parts that may still be in place from yesterday, which should look like this. Okay, so let's get all this other bits and pieces out. Button jumped out all by itself. Careful with this little tool. OLED. And then there we've got it. We've got our little Pico Iridium. It is unplugged. Next, grab your LED strip and fit these wires as follows. Place the red wire in the V-bus pin. Okay. the red wire in the not the VCP pin this time. So physical pin 40, we know that's all the way over here, this one. So we'll do J1 for that. The green wire, oh no, we're doing the black wire. Okay, fine. The black wire is pin 38, so that's just J3. And the green wire goes across to physical pin 34. So we've got 38, 37, 36, 35, 34. I believe that's J7. I'm going to double check. Yes, it is. If the wires are trying to pop out, just separate them a little bit to give you more flexibility of plugging them in. Now I'm hoping having the LEDs wrapped around like this should be enough. Next we need to add one of our buttons to the potentiometer. Fit them to the left of the Pico as shown below. Remember that your potentiometer will have a gap between each of its legs, unlike our diagram. Okay. Right, so let's get a button again. We're having it that the top left pin goes to, what is it, G30. If you can get that to sit in there, there we go. So the top left pin should be in G30 and the bottom left pin should be in J30. And now we need to find the potentiometer. What do we do with that? Oh yes, here it is. We need that to go, we're going to turn that all the way down and we're going to put the bottom left pin into J25. That's it. Okay. Let's move on to the next bit. Let's wire the button next. That button will need the usual 3.3 volts, not the 5 volts on the V-bus pin we're using on the LED strip. Connect the left leg of the pin to the upper red channel. So let's get a red wire. We're going on F1, sorry, F30, F1, F30 to the top left of the red line. Of course, it's being awkward. There we go. That's in. And then the right leg to the GPIO pin 15, physical pin 20. I'm going to use a yellow wire in this case because we don't have any blue ones. So that's F20, sorry, F28 over to A20. And then we also need another wire to connect the 3.3 volt pin, physical pin 36, to the upper red channel. Okay, so another red wire. We're taking that from, it appears to be I5. All the way across to the top right of the red line across the top. That should be fine. I'm just going to zoom in for a little moment so you can have a little bit of a look at what I've done. And hopefully I've got it 100% correct. You should always double check your own work anyway, just in case I've made a mistake, because I have been known to. Thankfully I haven't blown anything up yet, but it does happen. Anyway, so let's zoom back out again, so when we get some code going, we'll be able to see the RGB going, LEDs. Right, move on to the next bit. Oh, even more wires. Finally, we connect the potentiometer with 3 wires as follow. Connect the left leg, the ground pin, to the physical pin 18. So we'll use a black wire. we're going from F25. We're taking that across to, which one is it? A18. And then we're taking another yellow wire because this is a purple one and we don't have any purple. We're going to go from, what would it be if that's A25? That's going to be, yeah, we have to be careful with this because the way that it shows it on display is different from what we're doing. We need to follow from the pin in the middle, so as much as we've got A25 going, so not A25, F25, we need to go to F23 because that's where our middle pin is, and we're taking that across to pin 31. Pin 31 is 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31. Back onto F10 again, I think. Are we? Yes, we are. F10. And then we need a red wire to go from, for us, is, what pin's that? Pin 21. That would make sense. And we need to stick that into the top row as well. So I believe that's everything done now. Let's do another quick zoom in again so you can see where those wires have gone. Because as they already warned us, our potentiometer has a hole in between each leg, unlike the way that the diagram is. So we have to make sure that we're actually matching column for column of what we're doing. So that should be that now. Let's move on to the next bit. Activity 1. Minimal starter program, 1 LED. Time to twinkle. Plug in your Pico back into the USB port on your computer and we'll get this thing all lit up. Okay, finally they tell us to stick it in again. There's my connection now. There we go. Plugging it in. Now, whilst we could just straight into something flashy, no, go straight into something flashy and colourful with all the bells and whistles, we want to guide you through some easy example first, so you can understand how the code works. Some easy examples first. All right. This minimal example lights the first LED in red just to get to grips on how the library works, which is now included within MicroPython, so we don't need to install anything. Handy. These strips can show lots of different colors as they are RGB strips. Let's cover that first. What is RGB? RGB stands for red, green, blue. It is a color system used in computing to display colors on a computer display. The three colors can be combined to show a huge range of different colors. With RGB, each of the three colors can be set to an intensity value between 0 and 255. As each of the three colors has 255 possible different intensity values, technically there are 16,777,216 possible color combinations, although your eyes probably wouldn't notice a difference between a lot of these when they are used with LEDs. RGB with LEDs. How does this relate to our LED strip? Well, as we mentioned earlier, inside of each of these clever LEDs are three smaller LEDs, one red, one green, one blue. We send the code to the strip to set the RGB intensity value for each LED, allowing it to mix and show different colors. Cool, huh? There are lots of online tools to help you find RGB values for the desired color, such as this handy page from Rapid Tables. For example, basic red is 255 by 0, 0, 0. The code. Our example code imports NeoPixel, which is a name of the library now included in MicroPython to drive these kinds of addressable LEDs. To set the LED strip up, line 7 sets the pin number for the strip, GPIO 28, and the number of LEDs on the strip, which in this case is 15. We can now refer to it as strip in our code. To send the data to the LED strip, we first write that we want to do, then using strip.write to send it to the strip, a bit like how OLED display worked yesterday. In the example below, we use strip 0, which equals 255, 0, 0. The 0 is telling our strip to drive the first LED only, because the first LED starts at 0, the second is 1, and so on. That gets a bit confusing in computing, but it's something you do get used to. The number in the brackets are for the RGB values. We're using 255, 0, 0, which is red at its brightness intensity. Copy the example below to Thonny, run the code, then try the following tasks to get the hang of things. Okay, let's copy the code across then and see how far we get. Right, we run it. Well, first we've got to press stop, haven't we? Make sure that we found our Pico. Run it. And there we go. We've got red. It's definitely red. Okay, red. Anyway, try changing the 255 to 10. What happens? It should reduce the intensity. Okay. Change this to 10. Run that. And yes, it's got a bit duller, hasn't it? Alright. Then try changing the RGB value to 0, 10. What happens? It should change the color to green. Okay, so we have 0 here. We have 1 there. On that, and now it's green. Now what do we want to do? Now try changing the 0 to 7. What happens? It should light the 8th LED, because remember the LED numbering starts at 0. Okay, so we change this 0 to 7. And that one over there is now green. Okay, use an online RGB color finder tool to identify and display your favorite color. Okay, I'll let you get on with doing that yourself, because I need to try to get in through these examples and these activities. Alright. We'll stop that for now, but even so, the program's been stopped. It still lights because we have nothing to tell it to turn it off. Right. Our next step is to drive more LEDs in our strip. We'll first show you the basic method of doing this, then the more efficient method, and then a much better method which will keep your code nice and compact. To light more of our LEDs, we need to tell the MicroPython which LEDs we want to send the data to. So far, we've only told MicroPython to light up LED 0, the first LED. No, we haven't. We've told number 8 to do it as well. No, number 7, haven't we? Let's change this back to 0, just so we keep up with what they're telling us. Right, a basic way to do this is just to add more lines changing the 0 to whatever number LED will light up. The example below does exactly this, which will light up the first 5 LEDs in red on your strip. Give it a try, then keep adding additional lines until you have a line for each of the 15 LEDs in the strip. Then we'll show you a better way. Okay, we'll get rid of this one then. Start that, copy the code, and of course I'm going to tell you, and you should know by now, I recommend you write all of these programs out anyway, because it helps build muscle memory. Right, so we've run this first, and we've got the first 5 LEDs lit up. It wants us to do 15. So I'm going to cheat. I'm going to copy this, copy, put a new line, and I'm going to paste it, and put a new line, and I'm going to paste it. Make sure that's in the correct place as well. And then I'm just going to quickly go down, changing this all to the numbers it needs to be. And you should know by now what the last number is going to be. You're going to get it right. Have a guess already while I'm taking my time doing this and trying to remember how to type. Right, we've typed that all out. Now we run it. All 15 LEDs are lit. They are actually all lit, you can see. There we go. So that's that program done. A better method. Let's improve our code to save the number of lines we're using whilst making things a bit clearer. The only thing our code is changing is the pin number for each of the 15 LEDs. So we can make a use of a for loop and the range function that will be used previously. We use the for loop to iterate over each LED on our strip. We know we have 15 LEDs, so we use for I in range 15 to tell this code block to iterate over the range of 15. This range using I is injected into our LED strip that the line it uses a strip I equals 255, 0, It does this for the entire range of 15 LEDs. Then once the loop has completed, the final line writes the data to the strip, which makes them all light up. This still isn't the best way to simply fill the entire strip, but this example will be useful later on when we want to run some effects, so it's a good one to try. Try the example code below to see for yourself. We went for yellow this time. Okay, so get rid of this. It's a new one. Copy code and run it. There we go. Ta-da. So we've got nice yellow. It does look kind of white on the screen, but can you see? It is definitely yellow, not white. It's quite a bright white actually. Well, it's going to be, isn't it? Because it's full blown 255. Okay. An even better method. Want to simply light the entire strip without any flexibility. It's super simple. Just use strip.fill 255, 0, and it will light as many LEDs as you've defined in the setup line 15, which is 15 for us. Make sure you use 2 sets of brackets with this one. Well, yeah. Try the simple example below. Splash of turquoise, anyone? Then have a play around with the RGB color codes. Okay, I'll leave you to play around with color codes. As I've already said, I'm trying to get through this just to try to show what kind of output you should be expecting. There we go. Turquoise. It's more of a sky blue than a turquoise, but yeah. Right. Better color management. We now know how to light multiple LEDs and we know how to create RGB colors. Let's show you a few tricks to help you manage the colors a little easier, then we can move on to some really fun stuff. Your program currently uses the RGB values to set a color, but when you're looking back and reviewing your code, it can be difficult to remember what they are. A better way is to create color variables with colors named. Color variables. We've used variables a lot over the last 12 days, so you might already know what to do here, but we're going to show you just in case. We're going to take the example activity 2 and add variables for 5 different colors. We can then use these colors in our LED strip code to easily change the color by just using the color's name, such as strip I equals red. Give the code below a try and then try changing the color name in the brackets to the one from our variables. Okay, so get rid of the last one, copy the code, paste it, and then we shall run it. And there we go. What color would you say that is? It says that's red. What color have we used? Pink. It's right there in front of me. Pink. Okay. Looks a bit purpley, but pink. Let's change it to blue. Oh no. Yeah, blue. We'll do blue. And then we'll run that. There we go. Blue. So that's how that works. Color lists. Now that we have our color variable set up, we can also create a list of these colors which can use later in our for loop to iterate over, allowing us to work through a selection of colors in our code. But what are lists in MicroPython? Lists are another handy tool for your MicroPython toolbox. They're essentially a variable with multiple items inside. The items inside can be any data type, strings, integers, variables, etc. Simple! Let's run a quick example, then we'll use lists in the next activity. The short example below creates a list called myList and includes 4 strings inside square brackets separated by commas. That's it. Lists are as simple as that. In our example, we then print this list by using the list name variable in the print line. Pop this into Thonny and give it a try. Okay. Copy this code, stick that here, press enter, and then we've got dance it, press it, fix it. There we go. So it knows what it is. Activity 4, Light Chaser. Let's step it up a gear and create something really cool. A light chaser. How very festive. In our example below, we created a list of color variables called colors. We also have placed our LED code into the endless while loop, which contains a for loop with a nested for loop inside it. Why use a nested for loop? A nested for loop allows you to iterate over the colors first, then iterate over the LEDs. The code is saying for every color in the code list, run my code block. Then that code block then includes another for loop that runs this color through our range of 15 LEDs. Once the range has run it out, it jumps back to the initial for loop for the next color and does it all over again. We use J for colors and I for the LED range. If you remember from previous boxes, it doesn't matter what we use here. We could use color instead of J and LED instead of I. There are no rules here, just additions. Another key change is when we write the data to the strip. Earlier, the strip.write was outside of and after the for loop, waiting for the loop to finish setting all of the 15 LEDs before writing data. This time, we write the data within the for loop after each iteration, after each single LED is set. This means the for loop finds the next LED in range, lights it up before moving on to the next LED, which gives a chase effect to the LED strip rather than writing all 15 at all the same time. We also use a simple time delay before writing the data to set the speed for the chaser. That's a lot to take in, so try the code below and reread the above while watching it dazzle. We'd also encourage you to add more colors and play with the time delay, setting it to 0.01, make it super blinky. Okay, so copy the code, get rid of the last one, copy it in, run that. So there we go. That's pretty. I'll let you play around with speeds and everything like that. Activity 5, Speed Controlled Light Chaser. We're now going to reintroduce our potentiometer to our code and allow us to control the speed of the light chaser. We will use the potentiometer ADC reading and use this to drive the variable for the time delay, just like we did in box 4 to control the speed of the flashing LEDs. The code, we don't have to change our original light chaser code much to achieve this. We simply add the ADC to our imports, set up the GPIO pin for the potentiometer, add a line of code within a nested loop to read the potentiometer into a variable, then divide that number to make it more useful as a time delay. Use that reading variable to drive our time delay. Tip: if we didn't divide the sensor reading, we would be sending variables from 0 to 65,535 to our time delay as seconds, which would be far too slow for the effect we're looking for. Okay, copy this over to Thonny and give it a go. As you turn the potentiometer left, it should reduce the time delay and make the lights chase faster. You can change the number we divide the reading by to increase or decrease the minimum delay, or perhaps add some more of your favorite colors as variables and include them in the list. So I get rid of that, do this, copy this code across. It should get quite blinky now because I've already got the potentiometer turned all the way down. Vroom. Right, let's slow it down a bit. Let's make it go really slow. It's top speed, slowest speed now is to the right hand side, which I have to say sort of makes it feel it's the wrong way around in the way that we've figured out the variables. I would have thought that the lower the variable, the lowest setting would be the slowest speed and the fastest the other way. And I bet we can figure that out, can't we? At some point. I bet you can figure that out and change the code yourself if it does that. Maybe that's what they're going to tell us in the next one. No, next one's a button control. We're going to hop back into the strip.fill to completely fill our LED strip with a single color. However, this time we're going to use our button to change the color in the strip. This sounds simple, but we need to change our approach to make it work. Instead of entering the color directly into the code using something like strip.fill red, we're using a for loop to automatically iterate through a list of colors in order. We're going to use another method to which uses an index each color in our color list. But what is an index? Well, what is an index? Each time it is a list of given an index. This means that each item in the list is given a number starting from 0. Let's take our current list of red, green, blue. This index for the list would be 0, 1 and 2. 0 being red, 1 being green and 2 being blue. We can use this to pick up a specific color from our list by changing how we use the strip.fill line. For example, strip.fill bracket colors square bracket 1 square close square bracket close bracket close bracket. Wow, see, this is why I think it's a good idea to type all this out, because eventually it just becomes muscle memory. You start opening up brackets and then you realize that you need to be closing them at the end. Anyway, we'll use index 1 from the colors list, which is green. You're probably thinking, but we could just use strip.fill.green. This is true. However, as the index uses a number, it allows us to easily change that number and therefore the color with our button using variables. Our code also needs to know the length of our index, how many colors we have in our list, so that our code doesn't try an index number that is outside of our list's range. For this we use len. What? Wait, who is len? No, not len, len. We use len to return the number of items in our list. We simply use len followed by the name of the list in the brackets. In our list it looks like this: colors equal red, green, blue. Then we would use len to the following way to count and print how many items are in our list, which would be 3. Try the following quick example to see it in action. Okay, can we just put this here? No, that was in the wrong spot. Let's get rid of this. Go paste. Run it. There we go. 3. The code. This is where everything above should come together and make sense, we hope. Our code example below has some new variables. MyIndex, we use this as an index number to select the color from our list. We change this number from when the button is pressed to move into the next number in the index. Index length. This counts the number of items in our color list, 3 in our example. However, as we're using this to identify the last number in our index, we have to -1 at the end because there are 3 items in our list. But as these will be indexed 0, 1 and 2, we want the maximum index value to be 2. The example code below uses a while loop that does nothing, just a delay, until a button is pressed. Once the button is pressed, it uses the if statement to check that the current myIndex variable is. If the myIndex variable is less than the index length variable, myIndex is less than 2, it will add +1 to the index variable. We also use an else statement under this to catch when myIndex is 3, which rests myIndex back to 0. Regardless of whether this if statement or else statement has triggered, Both will alter my index variable, then move on to the code below them. These final lines of code update the strip.fill with the index number using the myIndex variable, then writes the data to the LED strip. We only write the data to the LED strip here, as this means data is only written when there is a change. If the button isn't pressed, nothing happens. Have a good look through the code example, then copy it over to Thonny to try it for yourself. I'll let you read through it. I really need to be able to get through this because this is going to be a long episode today, isn't it? So let's run it. Is it running? I hope so. Now if I press a button, there we go, all green, blue, red, green. So we're cycling through now every time I press a button and it registers the button press. Alright. Activity 7, fading. Let's try fading our LED strips in and out. It's surprisingly easy with some simple for loop code, and it gives us a chance to show you another way to use the range function. Our example below uses a while loop with 2 for loops inside it, both using a range function. These for loops iterate the red R value from RGB using the strip.fill line below them, so that each iteration changes the R value. You can see where we use I instead of the value in strip.fill I, 0, 0. Additional range parameters. You'll also notice that the range brackets contain 3 numbers, whereas previously we've just specified a single number to iterate over using 3 values. Parameters lets you specify the start of the range, the end of the range, and the step for each iteration. Our example below uses for I in range 0, 255, 1, which is setting the start of the range to 0, the end of the range at 255, and telling the code to increase by 1 step each iteration. What this does is change our red value by 1 step every iteration, starting at 1 and ending at 255. This creates a fading effect as the intensity moves from 1, dim, to 255, bright, very quickly using the delay we have set. The next for loop does the same thing but in reverse. Yes, you can go backwards with the range function. So we set our range to start at 255 instead of 1 and end at 1 instead of 255. This step is -1, so that we continually take 1 away from the starting 255 value. Try the code below, then try playing with the color variables. Try using I in other places such as strip.fill I, 0, I, or add fixed values to other colors such as strip.fill I, 0, 50. Okay, so let's get on with doing that. From the code. There we go, it's fading in and out now. That's nice too. Whoa, okay. Day 12 complete. This was a little longer than some of our other days, as the LED strips are such fun and versatile part to play with. And there's so much more you can do. We're pretty sure most of you will be turning your strip into a fancy monitor backlight. Perhaps some will combine it with the PIR to turn it into one of these motion front of your PC. Or maybe some clever hidden brake beam sensors will be used as a hand activated color changer. Whatever you make, we'd love to hear about your projects in comment section. Actually, go tell them, but also come back and tell me as well in my comment section. So what did we cover on day number 12? Today you have learnt what an addressable LED is and why they're so fun. Built a circuit with addressable LEDs, learnt about RGB and how to create colors with RGB values and where to find them. Learnt how to code addressable LEDs with MicroPython, learnt different ways to light the entire strip, some more efficient than others. Created color variables, learnt how to create and use lists in MicroPython, including list indexes. Used nested for loops, learnt how to use len in MicroPython. Faded addressable LEDs using a range, both counting up and down. over to you. That's all, folks. It's the end of the Maker Advent Calendar. We know many of you wanted this to last the traditional full 25 days. However, the world is a funny old place right now, and we wanted this to be affordable and accessible as many people as possible. Let's remember, this wasn't this Christmas, this was for the Christmas before, and we all know what was still sort of going on then. We really hope you've enjoyed following each day, and really hope you continue a journey as a maker, using your selection of components to make fun projects, experimenting using different parts together to make awesome projects. We've only just scratched the surface of what's possible with the fantastic little microcontroller and the components you discovered over the last 12 days. There's so much more to learn and experience. If you would like to expand your selection of components for Pico, the store is full of goodies. Be sure to check out our dedicated Raspberry Pi Pico section too. I'll let you click that all by yourself. More resources. The internet is jam-packed full of projects and examples using a Raspberry Pi Pico and MicroPython, and 99.9% of the information is free, so don't stop now! We've even had some great examples from makers in the comments section of the calendar along the way. Search engines are your best friend when it comes to making and coding. Forums, blogs, tutorials, social networks, user groups, and more are at your fingertip and hold an endless amount of examples, code snippets, previous discussions, and useful information. A good starting place for inspiration, a great community, is the Raspberry Pi forum, specifically the Pico section. Just don't forget to always search before asking a question. Oh, left them all out there. Alright, that's all, folks. Have a wonderful festive period and a happy new year from everyone at the PiHut. Oh, what can I say with me? Well, I'm going to turn this off now and make this full screen. Yes, it's been really fun going through both of these advent calendars. And if you're going, wait a minute, we're just on 12 days, please have a look at the other section. I did another one of this year's, and because this one's from 2022, and I've done the 2023 one as well, as both of which was a nice gift from my wife, so thank you very much to her. But I want to say as well, whichever religion you follow or day that you want to celebrate along this sort of time, have a great time with it. For those that are traditional with Christmas like I am, please have a Merry Christmas, a safe one, but a Merry Christmas. Have a Happy New Year. Don't forget to go down into the description, check out the links for Patreon and Discord. Don't forget to hit that like button, the subscribe button, and that notification bell for whatever videos I make in the coming days, months, years. But as always, happy gaming.